when you count. Like 40, I think, is 5 fractions, really. Yeah. Yeah, when you really think about it, you got to deal with all 5 of those fractions. So let's do it. 37. Alright, so when I look at the tab, I'm going to highlight it in yellow. Like, that's a subtraction problem, right? So if you can kind of ignore the whole bottom and just focus on the top of this fraction bar, this is just like the problems from yesterday. So I'm going to just work on that, bringing that to make a common denominator. Is this subtraction? It is. Okay. Now, while we were making a common denominator yesterday, it was emphasized that the expression should be in factored form when you pick your LCM. So, like, let's just go ahead and take the 4 out of that. There's a GCF of 4. So 8 divided by 4 is 2, and 20 divided by 4 is 5. So all I've done is factor a denominator. And now when I look at the two denominators, I see that they're really quite similar. And sometimes it helps for recognition purposes just to go ahead. For the ones that don't have parentheses, you can put parentheses around there, and then it helps you see how similar they are. So the first fraction is really just like the second fraction, besides that 4 out front. So for the least common multiple, which is the common denominator, it would have a 4 out front and then have 2x minus 5. So that's the common denominator we'll use to actually subtract this. And so you write it out twice. Your new problem with the common denominator. So yeah, that first fraction didn't have that multiple of 4 in it that the second fraction did. So we'll have to multiply that into the top and bottom. So 1 times 4 is 4. And the other one stays 7. The other one stays 7. And now we've changed it so that it has a common denominator we can actually subtract. So go ahead and subtract the 4 minus 7. Negative 3 over 4 times 2x minus 5. That's right. Right. So now when I go back to the original problem, I have that yellow part rewritten, more simplified, negative 3 over 4. The bottom doesn't really have to be rewritten, it's only one fraction. So that is all. That was step 1, which was simplify top and bottom by making common denominator. So step 1's done. Now we will rewrite it horizontally. You want to ask about the 4?
Oh, I figured it out. I thought it said for it, so it's like it's going up.
Yeah, it does. It is the way for a little bit, isn't it?
So wouldn't the 2x minus 5 just cancel out?
Well, first I'm going to go ahead and multiply by the reciprocal, so I'm going to rewrite it out again. I'm going to keep change, flip it. So that's -3 for 2x minus 5. Change the sign to multiplication and flip it. And now that it's multiplication, now we're going back to the previous section where we said, oh, with multiplication, you can reduce up and down and diagonally. So now I can reduce these. Same factors, reduce it. And then our final answer, -3 over 4x. How did it go, Callum? How far did you get? Here, stick with it. Yeah, stick with it. It was long. It was so long, it's in 2 parts. Parts on the whiteboard, parts on the screen. So long it is. The next one's even longer. It's 1 question, but I would say it's 8 different problems. So stick with it. Don't give up. Number 40. Does anybody have a question about 37? There will be 1 complex fraction exam. However, this chapter, which was graphing with asymptotes, simplifying, multiplying, dividing, adding, subtracting, we have yet to solve. Solving is a whole thing after the quiz. This chapter will be 20% of the final exam, roughly. You do have to have some of it. But a lot of the problems are much shorter. Like I picked these 2 really long ones to go over with you, but there are much shorter questions, aren't there? Number 40. You got the top, we'll call that the yellow part. Work that out. You got the bottom, we'll call it the blue part. Work that out, and then we'll look at it all together. Yeah. Sure. Somebody whistling out there, watch out. It's having a really nice time. Back to 37? Yeah. Okay, I'm going to rewrite the yellow bit, but while I rewrite it, I want to keep in mind that this would be better as 2 sets of parentheses instead of the way it is. So I want to factor that little guy, x squared minus 4. So how can we write x squared minus 4? Anybody know how to factor that? X minus 2 times x plus 2. So when I rewrite it, I'm going to do it like that. You're good so far. So far we just factored. Right, Kate? So now we need to figure out what the common denominator is. The common denominator we call the LCM, which is the least common multiple. Again, I think it's better, let's just put parentheses around this guy so we can see. The only difference between this one and this one is that the first one doesn't have x plus 2 in it. So if we want a common denominator, that first one would have to have not only x minus 2, but also x plus 2. We want the denominators to look the same. And this will be the common denominator for them. So I'm going to write it out twice. 2 new fractions with this denominator. So it would be
3 times x plus 2 over x minus 2 times x plus 2.
That's right, yeah.
We don't simplify it there yet.
I am gonna distribute it actually. So here's my two new fractions. So this one was different from the right side. It was missing this, so we'll multiply it in. When you multiply it in, you distribute it to that 3 that's there. So 3x plus 6. And then the second fraction doesn't have to change because it already had both factors. So now we've successfully made a common denominator. You can finish it up. Go ahead and do the subtraction. And that ends up being just 3x over x minus 2, x plus 2. So if you could follow along with that, that was pretty much yesterday's problems. Getting a common denominator and simplifying.
Wait, we weren't doing the reciprocal, or we ended up changing it into a multiplication?
So we're not done yet at all. So far, all we've done is we've simplified this yellow bit. But you're right. Cassie's right. We haven't done any of the actual fraction part. So now we're going to focus on the blue. We need a common denominator down there for the blue. Add those together. So this would be the numerator. Someone wanted to name it like the numerator of the numerator. They wanted a special name. Denominator of the denominator. And I don't have vocabulary for that. Maybe we could make it up. Oh, how did you think of that so quick? I'm really trying to think of something. That's it. The king never the king okay, so now this LCM, don't overthink it, don't overcomplicate it. Like, don't try to combine these. We're just gonna look at this as two different factors. And so it's gonna be actually the same as the top. We'll just include both of them, x plus 2 and x minus 2. Questions about how we picked the LCM to include both the plus and the minus. Yeah, you just gotta put them all in there. Include everything. Milo, what are you doing? Are you with it?
Yeah.
Are you still on the top?
No, I got two.
Right here?
Yeah.
Okay. Just asking if I'm going too quick. Can slow it down.
Yeah, I just wanted to put my notes, and you had a whole new equation up there.
Yeah. Just like that. Alrighty, so if I want these to have the same denominator, we'll have to multiply in whatever they're missing. So this first one didn't have the x minus 2 in it, so we'll have to multiply that in, and you'll distribute it. The second one has to have the x plus 2 put into the top and bottom. So I'm going to wait for a minute and let you distribute combined like terms, and I'll pick up on it in just a second. Reese, did you finish 40?
Yes.
Did you finish it?
Waiting for where I'm at.
Oh, you're beyond that?
Yeah.
Okay. Oh, so you finished the denominator. And you're ready to divide it?
Yeah.
You're ready to go back to the original format? Okay, you have it?
4x with 4 over x plus 2.
I think it's 4x minus 4. I want to say 4x
Oh,
minus
it is minus 4, yeah.
Alright.
I really
So 3x minus 6 for that guy. And then x plus 2 for the other. Now we have established common denominators. We can actually combine them. And that would be 3x plus x is 4x. Negative 6 plus 2 is negative 4. Okay, and this bottom bit was just like the problems from yesterday. So we've already done, in this one problem, we've done 2 questions like yesterday. We're going to keep it going. Okay, so I'm going to rewrite the problem. The top we said was 3x over
minus 2 times x plus.
the huge fraction bar, 4x minus 4. Okay, and then so now we're going to undo the complex fraction. Instead of it being stacked vertically, we're going to write it horizontally.
You have a eraser.
And then we're going to multiply by the reciprocal, keep, change, flip. And then we can, now that we have a multiplication problem, we can go back to reducing up and down a diagonal. And I see the x minus 2 diagonal, the x plus 2 diagonal. And all that's left is 3x.
That's it.
And that's it. So honestly, this answer is equivalent to that problem. We've just simplified it. Equivalent forms. So when you look at the example in your book, example 6 shows this and it calls it method 1. There is a method 2 that they show you, which you multiply everything by the LCM and it cancels. It's pretty neat. If anyone's interested in seeing another way to do it, you can look at that.
There's another test, maybe like a regular test where like some is on paper and some is on.
No, it's going to be like the midterm exam where it's entirely multiple choice. And it's like 15 vocabulary words and 45 math questions. Just like the midterm. All right, any questions on number 40? Yes.
We have to simplify the bottom and go 4 times x minus 1.
Yeah. So no, you could. It's totally equivalent. And perhaps typing in Big Ideas Math, they would like to see that better. So this is good. It's totally right to go that far. It would be necessary if it somehow we could reduce it after, but since we can't, it's fine to leave it either way. All right. So if anybody wanted to turn in the odds on paper, it's due right now. Does anybody have any questions about the odds? Oh, I lost 21. So here's 21. Okay. I spared you and I did not assign 22 today. Because 22 was like 21 in that there were 3 different fractions. So I'll take it. Thank you so much. So